Assalamualaikum and good morning. Okay. So first, don't forget to slide in your attendance. Use UTM Smart. And if you have any question, feel free to use the mic. Okay. You can stop during the session. Okay. So we will start in 1 more minute. So slide in quickly. Okay, Assalamualaikum and good morning. Can anyone hear me? Can anyone inform me whether you can hear me clearly or not?
Yes, Doctor. Yes.
Yes, Doctor.
Okay, good. So last week we learned about Kirchhoff current law, Kirchhoff voltage law. Okay, we learned about Kirchhoff current law, Kirchhoff voltage law, division rule, and circuit simplification. Okay, that is for last week. Okay, last week and for the first week. So this method is very useful, but it is not systematic. Okay, if you use a computer programming, you cannot implement this method because this is not a systematic approach, but it is very useful tool. So in the test or final, they will usually question you whether to use this method or loop or nodal analysis method. So today we will learn about nodal and mesh analysis method. Okay, so we start with nodal analysis. Okay, nodal analysis is basically we use Kirchhoff current law to solve the circuit. Okay, so from the Kirchhoff current law, you will get the node voltage. That's why I ask you to learn about node and as well as a simultaneous equation, because you will use these three theory in this nodal analysis. Okay, so this is the first step in doing nodal analysis. Okay, first you need to know what is reference node. Okay, this one you can learn in the discussion. Okay, so one of you asked about what is this symbol and this symbol mean. This mean a ground. Okay, so ground is basically voltage equal to 0. Okay, if you see this symbol, okay, you have to know that this is a ground and the voltage is automatically 0. So when you want to do nodal analysis, first you have to assign a ground to the node. Okay, one of the node. Usually you have to assign the reference at the common node. Means that the node with the highest number of branch, or the branch at the lower part. Usually this reference node, usually in the question they will give the reference node because we want to make sure that the answer is only one. If we don't give it, you have to assign it. Okay, that is the first step. Next, you have to label the node voltage. Okay, remember what is node? Node is basically the junction. Okay, this one is one node, this one is one node, and this one is one node. So if you look here, there are 3 nodes. So remember that the formula before. Okay, when doing nodal analysis, you have to assign n minus 1 node. Okay, so this is have 3 nodes, so you have to assign 2 voltage node. Okay, because one of the node will become a ground. Okay, reference node. Okay. Okay, now if you look here, it will, okay, this is become node voltage 1 or V1. This one become node voltage 2 or V2. Okay, what is to do next? In nodal analysis, you have to express the branch. After you assign the voltage, node voltage 1 and node voltage 2, okay, you have to assign the current, okay, the current direction. So you will use a consistent current direction. You cannot change during the calculation. If you change, you have to do the nodal analysis again. Okay, so for this case, for the current node, for the current source, you don't need to assign a current because it's already have the direction. Okay, but for the what you call the other node, okay, you have to assign it. So I suggest for simplification, you have to assign the current. Okay, if you start with V1, you have to assign that the current direction is moving from V1 to V2. Okay, or V1 to node to ground. Okay, basically goes out of the node. If the sign the direction of current is not assigned yet, you have to assign as go out from the node. Okay, this one go out at if you look at V1, it will go out of the node. Okay, and this one I2 also out of the node. Then at V2, because I2 is already assigned, okay, I suggest you just follow it. Do not change. If you already assigned the direction of I1, you cannot change the direction of I1 at the other node. Okay, and I3 also go out of the node. For I2 here, okay, the source current, okay, the source current, okay, this one is not very good because it has the same notation. Okay, make sure you use a different notation. So the current source, you just assign the direction. So after you assign the ground, assign the voltage node, and assigns the branch current, okay, you use Kirchhoff. You use this formula. Okay, for I1, okay, this one is I1. So basically, I1 is this direction. Okay. I1, the small one, the small I is going down. So basically, it's going from V1 to ground. So basically, V1 minus 0. Okay, V1 minus 0 because the ground is 0. So divide by R1. Okay, because the resistance here. This basically a Ohm's law. So what to do next? How about I2? I2 is the current move from V1 to V2. So I2, okay, the branch current I2 is basically V1 minus V2, okay, V1 minus V2 divided by R2. Then R3, okay, because it is from V2, okay, V2 to ground, so V2 minus 0 divided by R3, okay. V2 is the node point of the resistance, okay. I3 is from here to here. So V2 minus 0 because of the ground and divide by R3. So far okay? Are you still understand?
Yes, doctor.
Yes, doctor.
Okay. So what to do next in nodal analysis? Okay. So you apply Kirchhoff current's law. Okay. Current in is equal to current out. You can use this. Okay. So at node 1, or you can say that at node voltage 1, at node V1, or at node 1, so I1 goes into the node, okay, equals to, so this one goes out, I2, capital I2, small letter I2 and I1. So I1 equals to I2 plus V1 over R1, okay, minus 0 is already removed, simplified. and V1 minus V2 divided by R2, which is this equation. Okay, you just use all the equation you derived before. Okay, this one. So you use Kirchhoff current law, you get this equation. Okay, at node 2, also use the same way. So I2 goes into I2 and I2, okay, I2 capital and I2 small letter, okay, goes into the node. So if you look here, I2 plus this one is actually I2 equals to V2 divided by 3, which is this current goes out of the node. So you get the nodal simultaneous equation here. But the problem with this simultaneous equation, it is not in the standard form, and you cannot go, get into the calculator. Okay, so you have to make sure that the this one is in the simplest form. So if you look here, okay, you have to be careful. Usually the answer is wrong at this location, and the mark is quite large. If you you have to make sure that this is in the standard form. Okay, because this is nodal analysis, you have to make sure that the if you using simultaneous equation is x and y, right? But for nodal analysis is V1 and V2, or if it is 3 voltage node, you have to use V1 plus V2 plus V3 equals to something. So how to simplify this? Okay, first, okay, this one is, wait, I think it's hang. Okay. So if you look here, this one is just the current source is just what you call a constant, not a variable. Okay. So you put everything at this side, I1 minus I2. Okay, for this one, okay, you have to make sure that the denominator is the same because you want to add it. So R2, okay, I just use new one. So R2 V1 plus R1 V1 minus R1 V2 equals to I1 minus I2. So you have to group it. So R1 plus R2 V1 and minus R1 V2 equals to I2 minus I1. I1 minus I2. So this is a standard form. Okay. The standard form AX plus BY equal to C. Okay. So you now the R1, okay, R1 plus R2 is a constant, usually given, and I1 and I2 is also given. So you can just insert this value into your calculator. Okay, make sure that the constant here is after the equals to. Okay, so I show you another example here. Okay, same goes for this. Okay, okay, now I2. So negative V1 plus V2 divided by R2 plus V2 divided by R3 equals to I2. So you just move it here. Okay. So then this one multiply negative R3 V1 plus R3 V2 plus R2V2 equals to I2. So after this, you have to group it together. So, okay, negative R3V1 plus R2 plus R3V2 equals to I2. So you get the second simultaneous equation. So the first one is this one. Sorry, my pen is cannot work. Okay, this is the first simultaneous equation. So after you get these two simultaneous equation, wait. So you get two simultaneous equation. Okay. So you can solve this nodal analysis using your calculator. Okay. Then you get the node voltage. Sorry, my pen is not working right now. Okay. So after you do simultaneous equation, you get the voltage here, okay, and here. So you get the voltage this place and this place. Then after you get the voltage, okay, this is usually the answer. But sometimes the question asks you what is I3, for example. So how to get I3? You use the equation you used before. Okay. So I3, because you already to V2, you just insert V2 into the equation, you get I3. For I2, you also the same. You want to get I2, you use the V1 and V2 you get from your calculator and divide by R2, you get the I2 here. Okay. Then for I1 also the same. So if you want to get I1, you use V1 divided by R1. Okay. Okay, next the problem is this one. Find the node voltage in the circuit. Example problem. So how to do this? Okay. So you see here already give the reference, okay, the node, the reference node or the ground. So you don't need to assign anymore. And also it's already give the node voltage. Okay, this one is V1, this one is V2. So you don't have to do the first and the second step. Only the third step, which is assigning branch current. So what to do? Okay, assign the current. So remember you assign out, go out. Okay. So this is I1. Okay. This is I2. Okay. And for this case, it's already assigned the direction, so you cannot assign anymore. Okay. Okay. Next, assign the current at node voltage node 2. So I2 already assigned, so you cannot change. you only use one direction. Okay, so this one also already assigned the direction, so this one goes out. Okay, so this one is I3, and this one already assigned, so you cannot change. Now after you assign the direction, current direction, okay, branch current, so what to do first is apply KCL at node 1. Okay, so this is node 1, so current goes into and current goes out, so phi equals to this one is V1 minus 0. Okay, V1 to 0, okay, because this is ground, divide by 2. Okay, then plus I2. Okay, I2 is basically V1 minus V2. Okay, because it's moved from node 1 to node 2. So V1 minus V2 divide by 4. So you get the first expression. Then you have to change it to the standard form. Okay. So for V1, okay, you multiply this and this. Okay. Then multiply this and this. Okay. Plus 2 V1 minus 2 V2 equals to, if you combine this, you get 8. 8 multiplied by 5. So 40. Okay. Actually, you can simplify this. So this one is 6V1 minus 2V2 equals to 40. So you can simplify this more. Is 3V1 minus V2 equals to 20. Okay. So you get the first expression. Okay. First simultaneous equation expression. Now you apply KCL at node 2. Okay, here. So what is current goes into? Okay, there are 2 currents goes into the node 2, and 2 current goes outside node 2. So I2 plus 10 equals to, okay, I2 plus 10. Okay, then this one is 5 plus I3. Okay, I3 is this one. So I2 is basically use the same expression. So I2 is this direction. So V1 minus V2 divided by 4. V1 minus V2 divided by 4. Plus 10 equals to 5 plus. So I3 from V2 minus 0 divided by 6. Okay, I2 is from node 2 to ground. So you just express the equation. So then you move around to become a standard equation. So V1 minus V2 divided by 4, okay, minus V2 divided by 6, okay, equals to negative 5. Okay, then you simplify it more. So 6 V1 minus 6 V2 minus 4 V2 equals to 5, negative 5, 4, 6. Okay. So this one, 6v1 minus, okay, 6v1 minus 10v2 equals to negative 120. So this is your second simultaneous equation expression. Okay, so the first one is 3 minus 1, 20. 3 minus 1, 20. 3v1 minus v2, 20. So this is the first simultaneous equation. So using your calculator, you have to solve this. Okay. Okay, do not use manual method. You have to use your calculator. So somebody please use your calculator. Use your calculator, get the answer. Because you have to practice using your calculator to solve this. So you have to look at your video I give you before. So what is the answer? So what is V1 and what is V2? Anybody got the answer?
V1 is 40 over 3.
40 over 3. Use decimal point. When you give the answer, please give in the decimal point. Don't use fraction.
13.333.
13.33. Okay.
Okay.
Vote. And how about V2?
20.
20, 20 volt. So automatically you get the voltage. Okay. So automatically you get the voltage at node 1 is 13.33, and the voltage at V2 is 20. Okay. So you just apply nodal analysis, you automatically get the answer. So if, for example, the question asks you what is I3, so I3 equals to, so remember the formula, V2 minus 0 divided by 6. So V2 you have 20 divided by 6, you get 20 divided by 6. So you get 3.33 ampere. 3.33 ampere. Okay. So that is how you use nodal analysis. Okay, just a reminder, when you do simultaneous equation in your calculator, make sure you clear everything first. Okay, for FX 570 ms calculator, you have to shift clear. Okay, all. And for calculator FX 570EX, you have to shift number 9, then 3 equals to. Okay, make sure you're clear. If you don't clear your calculator, you will get the wrong answer. Okay. Next, I give you another example. Okay, here are another example. So for this case, okay, you don't have any ground, but they already assigned the node voltage. So automatically, okay, if you look here, there are 1, Okay. Okay, 1 node. Okay, 1 node, 2 node, 3 node, and 4 node, and 5 node. Okay, there are 5 node. But this one is a node with a 2 branch. So usually with the 2 branch, you just neglect it. So you don't consider the 2 node, a node with a 2 branch. So just remove this as a node. Okay. So how about this? Okay. And this, there are 3. Okay, but this one is already assigned. Okay. This one already assigned. So this one is still not assigned. So this one becomes ground. Okay. So that is how you assign the node voltage and the ground. Okay, let me clear this first. So assign the ground. Okay. So next, what to do is assign the branch current. So remember, if you look at V2, assign the current goes outside. Okay. So this one is I1, I2, I3. Okay. At node 2, okay, at node 2 here, you assign I1, I2, I3. Then at node V3, okay, at node V3, okay, because I3 already assigned, you have to choose the direction according to the previous assignment of the direction. So I3, then other is this direction, goes outside the node. So this one is I4, this one is I5. Okay. So after you assign the direction of the current, you apply Kirchhoff current law. So how to apply Kirchhoff current law? Okay, CL at V2. Okay, all goes out. So I1 plus I2 plus I3 equals to 0. Okay. So I1 is quite different because you have voltage source. Okay, if you can see here, there are voltage source. So how to do this? Okay. So for I1 is V2 minus 0. Okay. From V2 to 0. Okay. And because of the voltage source, okay, if you look here, it goes to positive. So if it goes to positive, you have to minus 10. Okay. If the direction of the current goes into positive, okay, you have to use negative. If the direction of the current goes into negative, you have to place as positive. So you have to invert it. So divide by 100 ohm. Okay. Then plus for I2 is V2. Okay. V2 divide by minus 0 because it goes to the ground. So V2 minus 0 divided by 1000 ohm. Okay, be careful with the unit. 1 kilo ohm is 1000. Okay, 1000 ohm. Then lastly, for I3, also use the same concept before. Plus V2 minus V3 divided by 2 to 0. Okay. So equals to 0. So be careful when you do this. Okay, if you they already assign you the voltage, not voltage, you just follow, don't change it. Okay. So simplify this. 220. How to simplify this? Okay. The easiest way is just multiply everything. Okay. Another way is you get the, if not mistaken, it's called factorial. So you have to remember the method, the mathematic. Okay. So how to do this? So easiest way is just multiply this both into here. So you can first cancel this, I think. Cancel, cancel, cancel. Okay. So 2200 V2 minus 22000, okay, plus plus 220 V2 plus 1000 V2 minus 1000 V3 equals to 0. Okay. So you can cancel more. 22 V2 minus 20, okay, plus 2.2 V2, okay, plus 100, okay, oh, 10 V2 minus 10 V3, okay, equals to 0. Then you have to make sure that it goes to a standard form. So 22 plus 2.2 plus 10, okay. So 22 plus 2.2 plus 10. Okay, if I have made any mistake, tell me, because this is quite a long simultaneous equation. Okay, P4.2 V2 then minus 10 V3 equals to 220. So you get the first simultaneous equation. Okay. So after you get the KCL at the second part, okay. So apply again at the V3. So apply KCL. PPLY KCL at V3. So I3 goes into and I4 and I5 goes out. So I3 equals to I4 plus I5. So I3, okay, as usual, V2 minus V3 divided by 220 equals to I4 is V3 divided by 1000. Okay. So I4 is from here, okay, from this V3 to ground. Okay, and then I5. So I5, the direction is from V3, okay, to 0, okay, divide by 220, and don't forget, because there is 8 ohm and the current goes into positive, so you just because it goes to positive, you use minus 8. So be careful, you have to invert it. So you get the expression for KCL. So now you have to change it to standard form, because usually you express this is 1 mark. Okay, another 1 mark is you change it into a standard form. So also the same. So for this case, this one is the same. So V2 minus V3 minus V3 plus 8 divided by 220 equals to V3 divided by 1000. So this one is V2 minus so 1000 V. Oh, so you simplify this. Okay. So 100 V2 minus 200 V3 plus 800, okay, equals to 22 V3. Then simplify it again. Okay, V2 V3. So 100 V2 minus 222 V3, okay, equals to negative 800. So this is the second simultaneous equation. So the first simultaneous equation is 4.2 negative 10 to 20. So 34.2 V2 minus 10 V3 equals to 220. So this is the first simultaneous equation. 34 minus. Okay, use your calculator. Okay, practice using your calculator. Somebody can give the answer.
V2 equals to 8.62.
8.62, Okay, V2 is 8.62 and V3
7.49.
7.49, 4849. Okay, so you get the answer. So you get V2 and V3. So if you want to get the current, okay, the branch current, you just insert the value, okay? Insert this value into the Ohm's law. Okay, for example, okay, if you want to get, for example, I5 equals to, so I5 is V3 minus 0 minus 8, okay? So divide by 220. So V3 is 7.49 minus 8 divided by 220. So you get negative 0.02. So negative means that the direction of the current, okay, your direction current is inverted. So I5 is basically negative 0.02. So you have to make sure that the meaning of the negative is the opposite direction. Okay, I think that's it for nodal analysis. So we can take a break first.
Doctor,
Okay. Yeah.
can I ask why just now the I4 no need to deduct?
I4?
Yeah, because at I2 got -0, but at I4 don't have -0.
Oh, because I just simplify it because -0 is just nothing, right?
Okay.
Oh, just that. If you want to write it, it's also okay. But if you don't want to write it, it's also okay, because it goes to the ground. So ground is 0. Automatically, you just cancel it.
Okay. Thank you, Doctor.
Okay. Any more question
Hello,
before
Doctor.
we proceed? Hello.
Just want to ask about the I1 when it enters the 10 volt. So the current become minus, yeah.
Which one?
The I1 which entered the 10 volt in the left side.
Okay. Enter the 10 volt. Okay.
So the current become -10, yeah.
Not current. The voltage.
Oh, the voltage. Yeah.
The voltage become minus. So you have to invert it. If
What?
goes into positive, become negative, and goes into negative, it will become positive.
Oh, only for the current, yeah, Doctor.
For the voltage source.
Oh, sorry, the voltage. Okay.
Okay. For the current, you just follow because it is in series, so it will follow the current source.
Okay, Doctor. Thank you.
Okay. So the class attendance, the system down. So can you see this? Wait. Hello.